So this video is going to look at sketching a parabola using completing the square. And one of the reasons that completing the square is useful is when the parabola doesn't actually cut the x-axis, and so therefore there are no roots. However, our procedure is to solve the equation and plot the roots if there are any. And obviously that's making f of x equals 0. Then we want to complete the square to find our turning point. And then we want to determine the y-intercept, so when x equals 0. And then we want to sketch the smooth parabola through these points, making sure that we remember our symmetry of our curve. Now the rules for using completing the square to sketch a quadratic function are: any quadratic function of the form y equals x minus a all squared plus b will have a minimum turning point at ab. Any quadratic function of the form y equals b minus x minus a all squared will have a maximum turning point at ab. And the equation of the axis of symmetry is x equals a. Now we need to note here that sometimes the completed square format is given in a slightly different way. So if we are given y equals x plus a all squared plus b, then the minimum turning point is going to be at negative ab, because we have to equate that x plus a bracket to 0 in order to get that constant term to be at its maximum value. So we want to sketch the function f of x equals x squared minus 6x minus 7. We want to indicate the roots, the turning point, and the y-intercept. So the first thing we want to do is we want to solve the equation and plot the roots. And we do this by equating our function to 0. So x squared minus 6x minus 7 equals 0. We're going to factorize x minus 7 upon x plus 1 equals 0. That means x minus 7 equals 0 gives us a root of x equals 7, and x plus 1 equals 0 gives us a root of x equals negative 1, and we're going to plot them on to our Cartesian grid at 7, 0 and negative 1, 0. Now we want to complete the square to find the turning point. So we're going to put our x squared minus 6x minus 7 in the format x plus a all squared plus b. So we need to separate the x squared minus 6x from the minus 7. So we're going to put that x squared minus 6x into a bracket. And we're going to leave the minus 7 outside. We're going to halve the coefficient of x. So minus 6 halved is going to add on negative 3 all squared. And then we need to take away that negative 3 all squared from outside the bracket. So the bracket for our completed square format is going to be x minus 3 all squared. And minus 7 take away 9 is going to give us minus 16. So to work out our turning point, we need to equate the x minus 3 all squared bracket to 0. So we've got x minus 3 all squared equals 0. And that gives us a value of x equals 3. And this is our line of symmetry for our parabola at x equals 3. And when x equals 3, the bracket equates to 0, so our function is going to be equal to negative 16. And that means that we have a minimum turning point because we have a positive x squared term in our function. So our minimum turning point is at 3, negative 16. So next we want to work out the y-intercept. So that's when x equals 0. So the value of f of 0 is going to be 0 squared minus 6 times 0 minus 7, giving us a value of negative 7. And we're going to plot that onto our Cartesian grid at 0, negative 7. And then we're going to sketch the smooth parabola through these points, remembering the symmetry of our curve. And finally, we need to label our curve with f of x equals x squared minus 6x minus 7. So our final example, we want to sketch the function of f of x equals 9 minus x plus 1 all squared. And you can see that this is already in completed square format. We have a negative x plus 1 all squared, so it means we're going to have a maximum turning point this time. The first thing we want to do is solve the equation and plot the roots. So we need to make our 9 minus x plus 1 all squared equal to 0. Then we can say that x plus 1 all squared is going to be equal to 9. We're going to square root both sides to get rid of the squared bracket, remembering that x plus 1 is going to equal plus or minus 3. So x plus 1 is going to equal 3, giving us a value of x equals 2, or x plus 1 is going to equal negative 3, giving us a value of x equals negative 4. And we're going to plot these onto our grid at 2, 0 and negative 4, 0. Now we've already got our equation in completed square format, so we can work out what the turning point is. We need to equate that x plus 1 all squared bracket to 0 to work out what the maximum value of our function is going to be. So if we say that x plus 1 all squared is equal to 0, then x is going to equal negative 1. And because the coefficient in front of our x plus 1 square bracket is negative, it means that this is going to have a maximum turning point. And when x plus 1 all squared equates to 0, the maximum value of our function is going to be 9. So the maximum turning point is going to be at negative 1, 9. And plotting that on, our maximum turning point at negative 1, 9 gives us a line of symmetry going through that turning point at x equals negative 1. We want to work out our y-intercept next, and the y-intercept is when x equals 0. So we're going to substitute in f of 0 to work out the value of our y-intercept. So f of 0 equals 9 minus 0 plus 1 all squared, which is 9 minus 1 squared, giving us a value of 8. So our y-intercept is at 0, 8. And finally, we're going to sketch the smooth parabola going through these points and then name our curve f of x equals 9 minus x plus 1 all squared.